Hello there. In this video, we're going to discuss how to calculate the net present value or NPV for annuities and perpetuities. To begin with, we need to define what an annuity or perpetuity is, right? So an annuity is a set of cash flows which can be constant or growing for a finite duration of time. It's basically a set of consistent cash flows, right? For example, if you're a bondholder, you might receive coupon payments every 6 months or every year for a finite period of time, right? Until the bond matures, let's say for 3 years or 5 years or 10 years, right? An example of a consistent cash outflow, it could be a mortgage payment. If you buy a house and you have a mortgage for 20 years and you're paying cash every month for those 20 years, and this amount could be fixed, and this represents an annuity, right? So the cash flow represents a type of annuity. Whereas on the other hand, a perpetuity is a set of cash flows which are forever, right? Again, they can be constant or they can be growing. An example of a perpetual cash flow is a university scholarship fund, for example. So let's say I graduate from a very high-end business school, and somewhere down the line, I would like to donate $1 million to the universities to set up a scholarship fund in my name. So I reach out and say, hey, here is $1 million. Set up a Professor Scholarship Fund. Okay. Let's assume that the fees for every student is $50,000 in this particular school. Okay. And the school doesn't just donate the money and say, okay, 20 students get the scholarship this year. No, they don't do that. What they do is they invest in something which is relatively safe and which can give them a certain amount of money every year. Let's say they're able to invest in something which gives them a 10% return every year. Okay, so $1 million results in $100,000 every year, and through which they can afford to pay the tuition for 2 students every year, right? As long as this $1 million is not depleted or taken off, they can continue to pay the fees for 2 students every year forever, right? That's why it's an example of a perpetual cash flow. Okay. In today's session, we're going to look at how to calculate the net present value of annuities and perpetuities. Okay. We're going to look at 2 different cases. One is when they have a constant cash flow, or when the cash flow is growing in a set pattern, right? It cannot grow in a very random manner. We're going to look at a fixed growth rate, and we're going to calculate the net present value in those 2 cases. Okay. We're going to consider a very simple example to begin with. Okay. I'm assuming a constant cash flow of $50 every year. Okay. To keep things simple, we're going to call them every year instead of every time period. So a $50 cash inflow, as in I'm receiving cash of $50 every year for a defined time period of, let's assume to be 4 years. And the discount rate I'm going to use in this case, let's say it's 5%. How do I calculate the net present value of this annuity? Why is this an annuity? Because it's for a set finite period of time, which is 4 years here. I've given for reference the formula on the right side here, how to calculate the net present value for perpetuities and annuities. We are going to use the formula and do it, but I'm also going to show you the alternate method of how to use just the NPV function and achieve the same results you get here. Okay. So for a constant cash flow of $50 every year, how do I find the NPV of the annuity? I'm going to use the formula which I've written there. Okay, so I'm going to take the cash flow. Because it's constant, it doesn't matter which cash flow you pick. And I'm going to divide that by the discount rate. Okay, multiplied by, well, you can watch the formula over there. 1 over 1 plus the discount rate to the power of. This set of cash flows is for 4 years. Okay, so it's for 4 time periods. And that should give you the NPV for this constant annuity of cash flow of $50 for 4 years. Okay, how do I achieve the same result without using the annuity formula, we know how to use the NPV function. You start with the discount rate, which is 5%, comma, value 1, and so on. So $50 until year 4. Okay, so this should give you the same result as when you use the formula. Okay, for a growing annuity, we need to assume a certain growth rate, let's say 2%. Okay, so we're going to assume that the cash flows are going to grow at 2% every year. Okay, so let's say 50 in the first year, but since then it's going to grow at 2% every year. So you're going to take that 50 multiplied by 1 over 2%. Okay, because I'm going to drag the formula, I'm going to block the cell there. Okay. Okay. So what do we see from these cash flows? That year 1 you receive $50. Year 2 you get $50 plus an extra 2%. So the cash flow has grown by 2%, right? And year 3 and year 4 and so on. Okay. How do we find the NPV of a growing annuity? Is we're going to use the formula again from as shown in the right side of the screen here. Okay, you're going to take year 1's cash flow. Okay, that's the first cash flow. Divide by the discount rate minus the growth rate, and then we're going to go 1 minus 1 plus the growth rate to the power of, again it's for 4 time periods, over 1 plus the discount rate to the power of, again, to 4 time periods. Okay, so this is the net present value of the growing annuity for this set of cash flows. Okay, again we can achieve the same using the NPV formula we learned, which is the discount rate, comma, we have the cash flows as such. Okay, it's a much simpler way when you have all the cash flows written down, right? One thing to remember about these 4 formulae in general is that the formulae are designed to calculate the net present value only when the cash flows start from year 1 or at the end of time period 1. Okay, we're going to see later in this video how do we adapt this formula if the cash flows start at some other point in time, let's say 3 years or 5 years down the line, or they start right now. Okay, moving on to perpetuity. We're going to use the same cash flows, but remember, a perpetuity is a set of cash flows which is forever. So it doesn't stop at time period 4. It goes on for years 5, year 6, year 7 until forever. Okay, how do we find the NPV of a constant perpetuity? Is we're going to take the cash flow, the constant cash flow, and divide it by the discount rate. Okay, so that's $1,000 is the NPV of a set of cash flows which is $50 forever. Okay, it might sound counterintuitive to think that, okay, receiving $50 every year forever is the same as receiving $1,000 today, assuming your discount rate is 5%. It's a bit hard to conceive this, right? So how do we interpret this is that think about the further down in the future you expect your $50, it's worth less and less to you, right? The $50 you get at the end of year 2 is worth less to you as compared to the $50 you get at the end of year 1, and so on, right? The $50 you receive at the end of year 20 or year 100 might be worth almost nothing to you, right? Because we are going to be discounting them depending on the number of years you need to wait, right? In the earlier videos, we've looked at the NPV generic formula where we discount the cash flows by the discount rate to the power of the number of time periods you need to wait, right? Okay. So as this kind of keeps decreasing, we see that it kind of resembles a convergent series in math, right? It almost converges towards 0, right? So the longer you had to wait, the $50 becomes almost worthless to you. So a convergent series can always be approximated to a single number here. In this case, it's $1,000. Okay. Next, moving on to a growing perpetuity. Okay, we're going to use the same $50 cash flow in time period 1. So we take that and we divide it by the discount rate minus the growth rate. Okay, obviously the NPV in this case would be higher than in the case of a constant perpetuity. Okay, now that we've seen how to calculate the net present value for annuities and perpetuities with cash flow starting at year 1, we are going to look at how do we adapt this formula when cash flows start earlier or later than year 1. Okay, so for this, we're going to look at 2 examples. We're going to just look at the constant perpetuity to consider it as an example because that's the easiest one. But whatever you learn here, you can adapt it to other forms of cash flows, right? To annuities and also growing perpetuities. Okay. So what do you do if your cash flows start right now? Okay. Instead of from year 1, if your cash flow starts right now, how do you find the NPV of this constant perpetuity? Is to find the NPV when the cash flows start from year 1, right? So you know to find the net present value of cash flows from year 1 until forever, right? So how do you do that? You have the cash flow at year 1, you divide it by your discount rate, which is 5%. Okay, this would give you the NPV only when cash flows start from year 1. But the cash flow at year 0 is already valued at present, right? It's already the present value. So all you have to do is just add that on top of what you just calculated. Okay, that's quite straightforward. Next, we look at what happens when the cash flow starts at a later point in time. Let's say from year 3. Okay, so to do that, I'm gonna use the regular NPV formula which we just learned. 5%. Okay, this $1,000 represents the net present value if cash flows start from year 1, not from year 3. Okay, this formula represents the net present value if cash flows start from year 1, as in the valuation is backtracked 1 time period and the valuation is as of year 0. Okay, so if my cash flows had started at year 3, this valuation is representative of my value as of year 2. Okay, now I need to bring this back to the present value or the valuation as of year 0. So I'm going to take this number, the $1,000, and I'm going to divide that by 1 plus the discount rate to the power of 2. Okay, this basically moves the valuation from year 2 backwards by 2 time periods. Okay, this number gives me the net present value right now. Okay, so in this session we've seen how to calculate the net present value of annuities and perpetuities. In the next session we are going to look at 5 useful Excel functions which delve deeper into this topic of multiple payments within a time frame, and we're going to look at mortgage payments as an example and see how to calculate the payment every time period, or how long you need to pay, or what the interest rate could be, and so on. Okay, thank you for watching.